In this tutorial, we are going to do applications of turning points to solve problems. Look at this example. The diagram shows a minor sector OMN of a circle with center O and radius R centimeter. Okay, so here we have a sector which is OMN. It is a part of the circle of center O and radius R centimeter. The perimeter of the sector is 100 centimeter and the area of the sector is A centimeter squared. Part A, show that A equals 50R minus R squared. Remember that because we have an area and a sector, then you should keep in mind the following. Radian measure and its applications. The formula of the area is half R squared theta, where theta is the angle inside the sector. And the length of the arc is r theta. Of course, we are going to use the differentiation. However, you should keep in mind these rules. Let's start. Area is half r squared theta. We do not have the theta, and we have the r, which is the radius. Okay, now we need to find theta. In order to find theta, we will make use of the perimeter. The perimeter is 100 centimeter, and it is the entire area of this sector. It starts with length OM plus arc MN plus length ON. All of these are equal to 100. The length for OM is the radius, plus MN, we will name this theta, so it is the arc opposite to theta. So it is r theta, plus ON, which is also r, equals to 100. 2r plus r theta equals 100. We need to find theta. R theta equals 100 minus 2r. We divide both sides by r, so theta is 100 over r minus 2. This is angle theta. Now we need to substitute it here. Half multiplied by r squared multiplied by theta, which is 100 over r minus 2. Now we will expand. Half r squared multiplied by 100 over r minus 2 into half r squared. 100 divided by 2 is 50. So here we write 50. R squared divided by r is r, minus 2 divided by 2 is 1, r squared. We reached the same result, so this is verified. As a recap, we wrote the formula for the area of the sector and we made use of the perimeter in order to find the theta. We obtained the answer, which is 100 over r minus 2, and then we substituted in the original formula of the area. And we organized the formula in order to reach the desired result. You need to know that this is the theta because we are going to use it in the upcoming part. Now for part B. Given that r varies, find the value of r for which A is a maximum and show that A is a maximum. If area is maximum, then it is a turning point. Thus, the gradient of A is equal to 0. A is 50r minus r squared. Now we will do the differentiation. It is 50 minus 2r. A prime is equal to 0, so 50 minus 2r is equal to 0. Minus 2r is equal to minus 50. We divide both sides by minus 2. R is equal to plus 25 centimeter. So when the radius is 25 centimeter, this area will reach its maximum value. Now we need to show that A is a maximum at this value. Thus, we will find A double prime in order for it to be a maximum. The second derivative should be negative. Okay, now let's do the differentiation for a prime. It is minus 2. Minus 2 is less than 0, so a is a maximum. Here we simply applied the concept of the turning points in order to define when is the area a maximum. Now for part C, the value of angle MON for this maximum area. Okay, so this angle is theta. That means angle MON is theta, which is 100 over r minus 2. And we know that at maximum area, the r is 25. We got this answer from part B. Now we need to substitute. Angle MON to be maximum is 100 over 25 minus 2. 4 minus 2, so it equals to 2 radian. This is the value of theta when area is maximum. Finally, for part D, we need to calculate the maximum area of the sector OMN. So we need to find the area, which is R is 25. Area is 50R minus R squared. Now we substitute. 50 multiplied by 25 minus 25 squared. The value for the area is 625 centimeter squared because we need to write the unit.